It arrived without warning, slipping quietly into our solar system, unnoticed by even the most vigilant skywatchers at first. A silent traveler from the vast, cold emptiness between the stars, it carried with it secrets from a realm far beyond our own. This was no ordinary asteroid or comet born of our own solar system. Its composition and motion hinted at an origin in the uncharted depths of interstellar space. Its trajectory was a clear giveaway. It was an interstellar visitor, the third of its kind ever to be confirmed, following in the footsteps of Oumuamua and 2I/Borisov. Designated 3I Atlas, it was hurtling through our cosmic neighborhood at a staggering speed, far too fast for the sun's gravity to capture it. Its velocity alone set it apart from anything we had seen before. The initial detection was just the beginning of the mystery. Astronomers scrambled to verify the data, realizing they were witnessing something extraordinary. As observatories around the globe turned their attention to this fleeting guest, the sheer volume of data became immense. Every second counted, as the object raced through the inner solar system. Scientists turned to Google's quantum artificial intelligence to analyze the object's movement, brightness, and trajectory. Advanced algorithms sifted through terabytes of information in real time. The AI highlighted anomalies that were deeply perplexing. The data didn't fit any known patterns, raising more questions than answers. This was not like the interstellar visitors that had preceded it. Its structure, speed, and unpredictable path defied easy explanation. 3. I-Atlas was colossal, its behavior erratic, and its path seemed almost too perfect. Some even wondered if it was natural at all. The discovery was no longer a simple astronomical footnote. It had become a priority 1 scientific investigation. The world's top minds were now focused on unraveling its secrets. The urgent task now was to gather as much information as possible before this silent messenger disappeared forever, taking its mysteries back into the darkness between the stars. The first assumption for any new object entering our solar system is that it is a comet. Initially, 3I Atlas seemed to fit this description. However, this straightforward explanation began to crumble under closer scrutiny. Its coma of gas and dust grew rapidly while it was still very far from the sun. Paradoxically, as it drew closer to the sun, the growth of its coma slowed down. This is the exact opposite of what we observe in every comet we have ever studied. The tail of 3I Atlas presented another deep puzzle. It was surprisingly faint and did not grow significantly in length or brightness as the object approached the sun. Furthermore, astronomers detected a faint, sunward-facing glow, an anti-tail feature never observed in any comet at such a distance. These inconsistencies forced us to question the initial diagnosis. To call 3I Atlas a comet was becoming an exercise in forcing a square peg into a round hole. The evidence was clear. 3I Atlas was not behaving like any comet we had ever seen. One of the most startling aspects of 3I Atlas is its sheer, breathtaking scale. Its immense size alone makes it a unique and scientifically precious specimen. Compounding the mystery of its size is its incredible velocity. It is a transient visitor destined to sweep through our solar system and exit without slowing down. Perhaps the most statistically improbable feature of 3I Atlas is its trajectory. The object is following a highly precise path, aligned to within 5 degrees of the ecliptic plane. It is making close approaches to Jupiter, Mars, Earth, and Venus in a near-perfect sequence. The combination of its massive size, high speed, and exquisitely aligned trajectory is deeply puzzling. Is it simpler to believe in a 1-in-a-million coincidence, or to consider that the trajectory is not random at all? The physical appearance of 3I Atlas has proven to be as baffling as its movement. This celestial body has captured the imagination of scientists and astronomers alike, challenging our understanding of the cosmos. When first observed, it possessed a distinct reddish hue, common among many distant asteroids and comets. This initial observation led to many theories about its origin and composition. However, as it continued its journey, the object began to change. Its transformation was not just subtle but rather striking and unexpected. Its reddish glow faded, and was replaced by an eerie green-blue hue. This shift in color was unlike anything previously documented in similar celestial bodies. This transformation was dramatic, linked to a change in its chemical activity. Scientists believe that the heat from the sun triggered a reaction, altering its surface composition. The object seems to be turning on in a way that is visually striking. This activation has led to a flurry of scientific interest and speculation. Beyond its color, the object exhibits a property that is truly without precedent. Its surface features are unlike any other comet or asteroid we have studied. The polarization of the light reflecting off its coma was extreme, placing the object in a class of its own. This unusual polarization suggests a unique interaction with light. It suggests that the dust particles in its coma have a structure or composition unlike anything we have ever encountered. This discovery could have significant implications for our understanding of cometary physics. This collection of physical anomalies paints a picture of an object that defies easy categorization. It challenges our existing models and theories. It is not behaving like a comet or an asteroid. Its erratic behavior and unique characteristics set it apart from known celestial bodies. Each new piece of physical data seems to push us further away from a simple natural explanation. The more we learn, the more questions arise. The object is an active, changing, and deeply enigmatic entity. Its mysteries continue to unfold, captivating the scientific community and beyond. The chemical signature of 3I Atlas is the most compelling evidence we've gathered. We've detected a significant outflow of cyanide gas. Alongside the cyanide, 3I Atlas is emitting nickel. What's strange is that we detect this nickel in the complete absence of any corresponding iron. An object releasing significant quantities of nickel but no detectable iron is a natural paradox. This unusual chemical fingerprint brings to mind industrial processes here on Earth. The fact that 3I Atlas is emitting nickel without iron is reminiscent of industrial refining processes. The combination of cyanide and nickel-only emissions creates a chemical profile that is bizarre. The chemical evidence forces us to confront the possibility that we are not looking at a work of nature. The accumulation of anomalies has split the scientific community into two main camps. On one side are those who argue for a natural origin. They contend that while 3I Atlas is unusual, it must be a natural phenomenon. The idea is that it formed in a distant star system with a different chemical makeup. This naturalistic viewpoint is grounded in the principle that we should not resort to extraordinary explanations until all ordinary ones have been exhausted. They emphasize the importance of Occam's razor, the idea that the simplest explanation is usually the correct one. On the other side are scientists who believe that the artificial origin hypothesis must be taken seriously. The sheer number of anomalies paints a picture difficult to reconcile with a natural object. They argue that some features are too complex to be explained by natural processes alone. The dark comet theory is an attempt to label the unknown with a familiar term, even when it does not fit. Critics of this theory point out that it may be a way to avoid confronting more challenging possibilities. We argue that it is unscientific to dismiss the possibility of a technological origin out of hand. The scientific method requires us to follow the evidence wherever it leads, even if it challenges our preconceived notions. The data is the data. It does not lie, but it can be interpreted in different ways. If the evidence points towards characteristics that are hallmarks of technology, we have a duty to investigate. Ignoring such evidence would be a disservice to scientific inquiry. The debate is about our willingness to confront evidence that challenges our place in the universe. Are we ready to accept that we might not be alone? The possibility that 3I Atlas is an alien probe forces us to consider the dark forest hypothesis. This idea suggests that the universe is like a dark forest, filled with silent hunters. If 3I Atlas is an artificial probe, its presence could have terrifying implications. A probe of this nature could be a scout, a silent watcher sent to gather information. Its precise trajectory would be suited for a reconnaissance mission. The very act of our own technological advancement makes us visible. The arrival of a potential probe suggests that our signals may have been noticed. The hypothesis forces a stark re-evaluation of our place in the cosmic food chain. The study of 3I Atlas touches upon the deepest existential questions our species can ask. The nature of 3I Atlas's trajectory imposes a strict deadline on our investigation. Its immense speed means it is only temporarily within reach of our instruments. We are in a race against the clock, coordinating observations to capture every possible piece of data. Key moments in its journey are being watched with intense anticipation. One crucial event is on the 3rd of October 2025, when it will be close enough to Mars for observation. If successfully imaged, it could provide us with our best constraint on the object's true size. Its closest approach to Earth will occur on the 19th of December, 2025. We cannot send a probe to intercept it. The object is moving too fast. We are relegated to the role of passive observers, forced to do all our science from afar. The window for detailed chemical analysis and physical observation is closing. The global astronomical community is working with focused intensity. The data we gather could define our understanding of interstellar objects for decades to come. As 3I Atlas continues its journey, we are left with more questions than answers. The object has become a cosmic Rorschach test, reflecting our greatest hopes and fears. We are confronted with an object that, according to our current understanding, should not exist. Its combination of size, trajectory, and chemical emissions defies all known natural precedents. The fundamental question remains unresolved. Is it a work of nature or a piece of technology? If it is natural, it would force a complete rewrite of our theories on planetary formation. If it is artificial, the implications are staggering and world-altering. 3I Atlas serves as a reminder of how little we truly know. As it departs, it leaves behind a question: what else is out there waiting in the void?